Yeah, good. Okay. So this lesson here, we're going to talk about examples of how to solve the quadratic formula by using that big gnarly quadratic equation, right? And then talk about the discriminant. So I'm going to give you three problems that we're going to start off with. The first one's going to be easy, okay, and then the medium, and then sort of the fastball pitch, right? So this is the softball pitch. So we're going to solve by quadratic equation. So I'm going to put QE for quadratic equation. Is that okay for you? All right. So here it is. Let's do 3x squared minus 5x plus 1 is equal to 0. 3x squared minus 5x plus 1 is equal to 0, okay? The first thing that we're going to want to do, all right, is we're going to identify A, B, and C, because after all, this is a quadratic. So what is the value of A in the quadratic equation? What is it? 3. Yeah, 3. How about B? -5. Good. How about C? 1. Yes, very good. That is the first thing that we do. Okay, the second thing that we do, I would like you to write down the quadratic equation. So it's x equals -b plus or minus the square root b squared minus 4ac all over 2a. Now, how many of you actually have that memorized? You used to. I told you in Chinese, right? Yeah, okay, good. So, yeah, I learned it in Chinese one year because my students said they couldn't do it in say it. 父辈家伙真正好比平方为2 2 that's as close as I can get to what my little yeah. Hopefully that'll be there. So let me know if I'm wrong, because if I'm wrong, I would like to change it. Okay. But for this part, okay, for part 2, I want you to focus only on what I've done and highlighted the part there. Okay. I only want you to do this in part 2. So that means I'm going to have -5 squared minus 4 times 3 times 1. Now, there's a reason I'm having you do this now. Because a lot of students, when they try to do all of this together in one fell swoop, many of them get confused, lost, and frustrated. And then you get angry, then you don't want to do it, then you don't like math, and then it's, it just spirals out of control. So I want you to break it up into steps. I would like you to do this part first. Okay, so how much is -5 squared? So positive 25, okay? Positive 25. What's 4 times 3 times 1? 12. So minus 12. So 25 minus 12 is how much? 13. I'd just like you to do that part, the second step. All right? Pretty easy, right? Then the third step. Here you go. Since we already wrote the quadratic formula down, we're going to use it. X equals, well, -b means I'm going to take the opposite of -5. What's the opposite of -5? So I'm going to have 5 plus or minus the square root. Now here's where all your hard work in step 2 pays off. Whatever number you get right down here, that's what you put. Divided by what? 2a. 2a. So how much would that be? And guess what? That's the answer. Now that was a heck of a lot easier, and we didn't mess it up. Okay? Mucho fast. Now, this is an exact answer. What do I mean by that? Yeah, there are no decimals involved, right? This is an exact answer, and we're going to assume that the book wants us to find the exact answer every time, unless it states specifically no. I want you to round to a certain decimal point. Do you guys understand? Okay, great. So that is the first one. That's the softball pitch, right? All right. All right, let's do this one, all right? Let's do 9 plus 3 divided by x minus 2, 9x squared. There we go. So this is where we're at now. We multiplied everything by an x squared, okay? Now we're in quadratic land, right? Okay, so now we're back to step 1, right? What's step 1? Figure out A, B, and C. A is how much? 9. B is how much? 3, and C is how much? -2. Step number 2, we're going to write down x equals -b plus or minus square root b squared minus 4ac, all divided by 2a. So that means I'm going to have, I'm going to do the discriminant part first. Well, I'll tell you, we're going to talk about that in just a second. So I'm going to do 3 squared minus 4 times 9 times -2. Now, please be very, very, very careful here. There are 2 minus signs. I do not want you to mess it up. So 3 squared is 9, okay? Now, what's -4 times 9? Negative 36. What's negative 36 times positive 2? I mean, sorry. Negative 36 times negative 2. Positive 72. So this is 9 plus 72. Okay? So which is 81? Hey, 80, which is a perfect square, and we're going to take advantage of that in step 3. So x equals negative 3 plus or minus the square root of 81 divided by 2 times 9, which is 18. You guys with me so far? Okay, now, can I keep going?
Yes.
Why can't I keep going? Because 81 is a perfect square. You guys are on the right track. So I have negative 3 plus or minus 9 over 18. So I have 2 directions I can take this problem. I can take it the positive direction or the negative direction. Ian, you still with us? You got it?
Yeah.
So that means I have negative 3 plus 9 divided by 18. Or I have negative 3 minus 9 divided by 18. Because it says plus or minus. So I have to actually go with both of those.
You have to show both of those.
You do? I'm so sorry. Yeah. Okay, so negative 3 plus 9, that's 6. 6 over 18 simplifies to what? 1/3. Yeah. Well, that's not so bad. All right, negative 3 minus 9 is negative 12. Negative 12 over 18 is negative 2/3. Good. So how many solutions do you have? So what is the solution set? 1/3 and... Okay. 3x equals 1 minus 1 over x. Who's got a good idea? It's the same good idea we've been using in last night's homework and today's. Yes? Multiply everything by x. You have got it down. When we multiply everything by x, nice things happen for us. So let's see here. X times 1 over x, how much is that? 1. Minus, what's x times 1? X. What's x times 3x? 3x squared. Now, I should write this in standard form, shouldn't I? Yeah, so 3x squared minus the b squared minus 4ac part, okay? So this is where we're at. We're going to figure out the b squared minus 4ac part. So I'm going to have negative 1 squared minus 4 times 3 times 1. How much is negative 1 squared? 1. 1 minus 12 is how much? Okay, you can't have that, right? No solution. You can't have that. Okay, what's really going on here? What do you mean that there's no solution? You can't have the square root of a negative. Why not? You can't have the square root of a negative. That's it, right? So the answer is no solution. That's it? That's where once we get over here, and I totally did not record any of that, great. The real answer for us then, there is no real solutions.
So instead of no solution, it's no real solution.
That's right. Instead of saying no solution, I need you to write no real solution. No real solution. Yeah, but it wasn't. It would have been more boring. It would have been boring, right? No real solutions. And go on. I hope you have the context of infinity and numbers down. Okay. All right, great. I need a 2-minute break to recover from my story. So, what's another way of writing greater than 0? Positive, right? Positive numbers are greater than 0. Then, right? Then there is 2 real solutions. Okay? If your discriminant is actually equal to 0, then there's only 1 real solution. And finally, the third one is if your discriminant is less than 0, what do you think?
No real solution.
Then there are no real, very good, solutions. But in fact, there are how many imaginary solutions? No, there are 2 imaginary. There are 2 imaginary solutions. Huh?
They're actually called imaginary?
Yeah, there's it's the imaginary number system. But for you guys, okay, I need your help in recalling these. So we say that there are 2 real solutions, 1 real solution, and then no real solution. And I want to bring these up, okay, and talk about the graph for a second. What was the first equation that we did? Yes, Riley, what is it, buddy?
I brought my hand back down.
Oh, what's the very first one that we get, you guys? What is it? 3x squared minus 5x plus 1. So 3x squared minus 5x plus 1. Okay. What am I going to do here? There it is right there. Okay. So, check this out. Alright, a slow process here, right? What are we noticing about this particular parabola that we've graphed? 3x squared. What do you mean there's two solutions? Okay, why are we using the x-axis here? What's so big about the x-axis? What does it represent? Not the variable. It represents the real number line. You guys ever realize that? The x-axis represents the real number line, and we can see clearly here that there are two solutions, and in fact, there they are, right? It's where that graph. Okay, so when we graph this one, right, we're noticing that the discriminant was equal to 0, so it only touched the real axis one time. Easily see now, right, when we zoom in on that one, that the graph never touches the x-axis or the real number line, so there are no real solutions, and that is why.